What? Can you hear me there in the back? Yeah. Okay. So it's really great to be here. It's my first time in Argentina, and the meat is great.
So man.
And well, I get to do it doing small talk, and that's always a pleasure. By the way, just for the fun of it, how many of you have extended object or string or collection with at least one method in your life? I mean, isn't that hilarious to ask this question? I mean, look, the reaction was, oh, what a funny question. Because it's like a no-brainer that at some point you're going to do it, right? Because, Faro is great. By the way, how many of you are working in Faro? Excellent. Smalltalk is great, Faro is greater. And the point here is, but it doesn't matter how great it is, you still want to customize it for whatever is important for you and for your particular business. And this is one thing, I think this is a great feature of Smalltalk that doesn't really exist in other languages. In other languages, whenever you need to customize anything, you basically you need to wrap. And all of a sudden you have a ton of classes there. So I'll get back to this particular question a bit later. What I want to talk to you about is Moose. Any of you heard of Moose before? Right. Now, but before we talk about Moose, and maybe you've heard, for those that didn't, Moose is a platform for software and data analysis. And today I'll be showing you what that means. But before I go into the details of the technology and do demos and so, I want to talk to you about something else. So if you go on the web page, then you see that Moose enables something called humane assessment. Any of you knows what humane assessment is or heard of it before? Okay, great. So for the other ones, that's what I'll be talking about. And if you go to humaneassessment.com, that's basically it's the philosophy behind Moose. It's like a tool is great, but if it doesn't have a good philosophy, it's like it doesn't have soul. So I want to take a bit of time and talk about what that means. And first of all, I want you to step a bit back. And let's think about the meaning of, how many of you are developers here? Excellent, that's great. I love that. Whenever we talk about development, it's such an empowering thing to be a developer. Can you give me a synonym for development? Maker, builder, right? This is it, and it's such a great thing. I mean, you build something, right? That means, what does it mean? Well, it means now I don't have it, then I build it, and then I have it, right? It's like creation at its best. You build something, it's so sexy, it's so amazing. It's an amazing feeling. You fall in love with your programs? Yeah, you see? Especially that they are written in Smalltalk. Now, the only problem here is that for about half of the time, at least, you're not developing anything, even when you're in front of your computer. You're doing something totally different. And that is, you're trying to understand what you have in there. This is the other side of the story. This is the not so sexy side of the story. There's no mission behind it, really. It's not like, okay, now I'm going to create the product that will save the world. It's, now I have to figure out, how my system is so that I know where the damn error comes from. And this is what I want to talk about. And I call this particular task assessment, where by assessment I understand understanding a given situation enough to be able to make a decision at the end. Right? The goal of this process, the goal of this, by the way, huge expenditure, we're talking about half of the development budget here. The goal here is to get you enough information and put you, to bring you enough knowledge such that you can basically make a decision afterwards. Okay? This is the goal of assessment. Now, if you think about it, for the left side of the story, we have a ton of know-how. We have patterns, we have technology, we have all sorts of best practices, and what's more important, we have the budget that is allocated there. Right? If you look in the Excel sheet of a manager, then you will see, there is something associated to analysis, there is something associated to architecture and design, there is something associated with development, hopefully something for testing, but those things, the building part, they're prominently there. We actively think about them, and we approach them in an explicit manner. But what about the other one? We don't do much about it. In the end, actually, let's take a closer look. Basically, assessment, we say, well, you have a bunch of data. It can be your system, the source code, let's call it like that. It's just data in general. And then somehow you do something, and you want to get enough knowledge. Now, the thing there is the way this particular activity is being undertaken is basically by people reading code. This is what actually happens. You start reading code. And, on the one hand, it's a pretty natural way of approaching the problem. I mean, when you build it, you introduce characters, and then when you're understanding, you're going to, read the characters that you wrote in there. That's okay. Now, the only tiny problem is that that's not a tiny system. It's a pretty large system. So if you do the math, if you take a reasonably small system, let's say 250,000 lines of code, and you say you read pretty fast, let's say 2 seconds per line, if you do the math, it will probably take you a man-month of work to read the whole thing. Just to read it. Right? This doesn't really work out. So what happens in the end? Does any of you actually go and read the whole code? No. You're going to read enough, and then you say, well, I think I have enough information, and then I'll extrapolate, and then I'll just put my fix in there, and then that's it. I go on. So in the end, most decisions are actually very, very local. And the rest of them are based on what we believe the system is. So that's the challenge. Challenge number one is the size of the problem. So if you take a look back, what you don't want to do is you don't want to just rely solely on code reading. You don't want that, because it simply doesn't scale. So what's the other option? Well, the other option is to, you use tools, right? Because that's what we know. You have some data, you apply some tools, and the promise that, this is not a new thing to use reverse engineering tools or software analysis tools, depending on how you want to call them. Analysis means, just getting some data and producing. For a while, people thought, you're going to produce instantaneous knowledge. You buy the magic, by the way, you have to spend a lot of money on the tool. You buy the tool, you press a magic button, say, here's my source code, and then I'll get instantaneous knowledge. That somehow, we tried very hard for about 20-something years, and somehow it doesn't work. I don't know why. Most likely it's because the result of an analysis is nothing but another piece of data. It's just another piece of data. Okay, it's a model, it's most likely reduced piece of data, but it's another piece of data in the end. It is still required, we still need human effort to go and understand that thing in order to gain the knowledge. Because knowledge must be inside our heads. So this is part number one. Assessment is primarily a human activity. And it is us that we should be able to be in charge of it. So on the one hand, we can't scale it by simply manually approaching the problem because of the size of the data. On the other hand, we still need to be able to be in control of the tools that we are using, because only like that we are able to understand. Okay? So, questions? By the way, you can ask questions at any moment. Great. So, let's move on a bit. Now, again, here, these kinds of things, this picture here was pretty much used, and then there are plenty of tools out there. By the way, you know, when somebody's not looking, are you still programming in Java? Any of you? So, right. Now, if you are, or other languages maybe? Right. If you are, let's say, for example, if you're working in Java, you might have heard of something like, you know, various kinds of analysis tools that you can just plug in, you press a button, they give you the results, and then the only difference to, you know, using or not using is that now you have 10,000 warnings more. And that's it. One thing you should always ask whenever you're using a tool, doesn't matter how interesting the tool is, how much it costed, what the marketing around it is, there is, to me, only one unit of measure for such a tool. And this is this. When was the last time you've ever used it to take a significant decision based on the output of the tool? If you don't use it for anything, if it does not affect your behavior after using the tool, it was not useful. That's the only, in my mind, the only relevant measure of success of an analysis tool. Did it affect your assessment or not? Okay. So, one problem with this kind of an approach is that, well, data is not only large, but it's very highly contextual. It doesn't really look uniform. You know, if I take one system and compare it with another system, even if they are written in the same language, even if they approach the same business domain in the end, they will look totally different because various decisions will be taken in the two ones. They will not be the same. That's why the system is contextual. So if you treat it just like a simple, you know, a uniform thing, you will only capture the generic part of it because this is the only thing that is reusable, right? If I take a system that is here and then I say, oh, I need to make a tool that works on this system and I need to make a tool that works on the other system, then by definition this tool must be generic enough such that it works on both systems. And if we target the end user, like the end report only, then, well, it's most likely not going to work properly. Or it does not capture the most interesting part of it. So another way of approaching this problem is going like this. So first of all, we say analysis is never linear because problems are rather complex, and I always need to take pieces of information that are relevant or contextual to whatever system you're working on. I always need that. So instead of having a linear process, we propose another one. So we say you get the data, you import it, you build a model out of it, then you apply an analysis. And the critical part is that the result of that analysis is another piece of data that can be worked on. So you want to be able to work and work and work and combine different kinds of points of views until you figure out what you wanted. Okay? So this is the idea number one in Moose. And this is what brings me to the technology part. So I'm just going to give you a brief demo now. So what I have here is I have an image of Moose, which is based on Faro. It was built, I think, last night. And so it's just taken directly from the continuous integration server. And what we have now is, now in this image there is a Moose specific menu in here. So here I'm popping up Moose panel. In this case, I've already imported Moose itself in Moose. So I went through the trouble of creating the Moose model, right? So basically, this is another representation of the code. So let me show you a couple of things here. So this is the basic interface of Moose that you're looking at right now. And it's called the Moose panel, which inside it has a Moose Finder kind of tool. And now when I click on this, on Moose, on the model, what I have here, I have all sorts of pieces of information. For example, I have 1,373 classes. So if I click here, I see them over onto the right. Or I have all the methods. I have 16,000 methods. Or I have 3,771 attributes. Or I have 97,000 accesses. That means a method accessing a particular attribute. Right? So I have a lot of pieces of information. I even have the comments in my source code. So they are all represented as first-class objects. So I have a very rich object model representing my system. Okay, so now what kinds of things can I do with this tool? Well, first of all, I can play with navigating. So now it's not only that it shows me here to the right, but now if I click on one, I can just display more information about it on the right-hand side. And so now I clicked on one particular class. In this case, it's called GLM Stacker. I can, if I want, take a look at all these methods. It has 3 methods. I can click on the method, and if I want, I can see the source code over here. Or I can take a look at other things. For example, different kinds of properties that I have on the right in here. So in this particular method, I see that there are 2 accesses to a variable. So let me see what that means. One access is over here. One access is over here, right? So there are 2 read accesses. That I have 0 comments, that I have 0 conditionals, that I'm invoking one method. Then there are 2 lines of code in total, and so on, right? So these are various kinds of properties. And these properties can also be accessed at the level of the entire class. So in the class here, I have properties that are related to, for example, the number of methods in the source code, in the particular class. So I have 3, I saw that. There are 0 attributes. There are 2 comments in total, and so on and so forth. Okay, so that's something I can do. So now I saw, for example, oh, okay, I have number of methods as a property. So then I can just say here, number of methods. Could you please give me if there are classes that have more than 10 methods? And apparently, now I'm doing kind of a select. And apparently now out of 1,373, I have 389 that have more than 10 methods. Now, let's see, do I have more classes that have more than 50 methods? And apparently there are 50 classes that have more than 50 methods. Let's see if there are classes if there are more than 100 methods. And apparently there are 14 classes that have more than 100 methods. For example, one of them is famix type. So that's interesting. So if we want to take a look at it, this class has 328 methods and counting. We'll probably get back to it a bit later. Okay, so now you get a bit of a feeling. Okay, so I can start quickly, play a bit with it. I can navigate through my system. If you saw, the first thing you're looking at right now is not source code, by the way. It's a different point of view. It's something that you probably don't experience in your code browser, because the very first thing you're looking in the code browsers is source code. So yet another thing we're doing, so not just necessarily only metrics, but another thing we're doing is visualizations. So for example, if I click here on this tab, so I have all the classes, and now all of a sudden I'm seeing here a picture of all the hierarchies in my class, in my system. So for example, here I'm seeing, okay, there are some, oh, look at this one. There's a pretty large root of a hierarchy in there. Let me go a bit more. Oh, I see here this is a large hierarchy over here. What's the name of this? Oh, this is famix type. And now if I click on this, I see the details on the right-hand side. So it's interactive too, right? Again, I'm presenting the information in a slightly different way, and then I can just continue navigating. It doesn't matter. It doesn't have to be a list, or it doesn't have to be a link. It can be anything, and I can just move on. Okay, so that was pretty interesting. Now, actually, I would like to see this a bit larger, because given that the screen here is only 1,000 pixels wide, I would like to see it on the full screen. And to do this, everywhere you see anything in Moose is that we have an object-oriented design also to the user interface. That means you're always exposed to data, and you can always just click on the data and obtain the kinds of unary methods that you can work on, that you can apply on it. So for example, here I'm just right-clicking on all the classes in my system, and I say, well, could you please spawn me the visualization showing all the hierarchies in my classes, right? So if I'm here, then I was saying, okay, at some point there is this very large hierarchy, and here the root of this hierarchy is called Moose entity. And yes?
Can I ask you something?
Yes.
Can we put the microphone because it's sounding in the online program?
Okay. Okay, so then I mean I have to use this one afterwards as well. Okay. So, coming back. So we said, well, you know, I'm here. This is a picture, right? It's not, I cannot just drag and drop it. It's just, I can also right-click on it and then obtain its menu. And then I say, eventually, if I want, I can always go and browse, open my browser if I want. So I can always go to the source code when I want. The question is, when do I want to go to the source code? That's the key question here. Okay? And it should not be an a priori assumption that I should start from the source code. Because that's just a tiny detail that you're looking at. You know, when you're looking at a method like this, you are somewhere, you know, you're looking at the needle in the haystack. You don't know whether there are more or not, or this is the right place to look at. Okay, so that's a bit of the idea, right? It's a very lively environment, and you can always click on something and then you go on, and you ask more about it. And you can start combining things as you move along. Questions? Yes, I have a question.
What about the microphone?
Okay.
No, I understand your point, but when you go to look at the source code, it's also because you want to understand the semantics of your object.
Right.
And here you,
And here you just see how many methods, how big the hierarchies are, but you're not understanding what the system is doing, what is modeling the system.
Excellent question.
You told me that.
Yeah, I know. So the question here is, you know, when you're looking at all these pictures, you pretty much get, you know, yeah, it looks nice, you have hierarchies, you have methods, you have classes, and they have some sort of relationship, and we can play with a bit of queries here and there, but the juice is not there, is it? You might have noticed that basically up to this point, I only mostly clicked around. And I can tell you this is not where value is. This is precisely it. If you're using this tool, like I just used it right now, you're missing the whole point. It's not, I just showed you what the tool can possibly do. What you do with it, it's a different issue. So, now let's see. Let's ask another question. Let's ask something that has some sort of a meaning. And, well, you know, I mentioned here, look, there's this big hierarchy. This big hierarchy, now you're asking me, I'm the expert in this area. And I will tell you, oh yes, in this hierarchy, this is where we're modeling information, right? This is the meta model. It's called phonics. Every entity has to inherit from Moose entity. And wow, that's great. But by the way, and then I will tell you, we are meta-describing all these entities in using another engine called FAME. And it's great. And then I'm the expert, and I'm the reverse engineer, the assessor now. And then I'll ask you, how do you meta-describe these pieces of information? And then I'll tell you, no, now I'm the expert. And then the expert says, well, you know, we just use annotations. So what do you mean? Well, basically, if you look in a class, in the methods, basically for every setter of a relevant property, we put an annotation in there. And then for the whole class, in this hierarchy, we will have a class-side annotation that describes the whole class. And then what do you do with this information? Well, then based on this information, we can serialize, you know, input-output kind of, we can serialize the models easily. And every piece of information that you're basically seeing here is, in this browser that I'm showing you right now, this Moose panel, is highly dependent on these meta descriptions. Okay, so all the properties that I listed are basically queried from the meta descriptions. So it seems to me like these meta descriptions are pretty important. Let's quickly see. Are there any meta descriptions or are there annotations in this Moose model? What kind of annotations are there? So I have here, you might have noticed here, I have here something called Famix annotation types, and there are 31 of them. And well, it looks interesting. And for example, one of them, I see there are some that are called MSC, property, type, opposite, and then all of a sudden the expert says, yes, this is the particular property, this particular annotation we're using to define a property in our model. So what does that mean? Well, let's see. Now I'm looking at the places where this particular annotation is being used, and apparently there are 90 places of these. And so if I click on one of them and I look at the source code, I can see, okay, so there's this MSE property kind of a pragma here, right? This is an annotation in our terms. And I see also that there is something called multi-valued and derived. This is other pragmas. And there is MSE comment. And then I'm asking, what are you using this MSE comment for? Well, basically we're using it to describe, so to produce documentation about our system. Oh, so basically that means that every time you have like an MSE property kind of a pragma, you should also have an MSE comment kind of a pragma in the same method? And then the expert will say yes. Oh, so okay, can we quickly check if there are places that don't follow this particular rule? So let's see. So I said, well, let's go back. So I said all the annotation types. I'm clicking on the MSE property type opposite one. I'm clicking on all annotated entities, and this will be a group of basically of methods. And here I would simply say, well, could you please give me those that are also annotated with MSE comment? Annotated with. And out of 90, I have 54 of them that are annotated. So that means that 36 of them don't have MSE comment in there. So that's interesting. Let me check. So if I go here, oh look, there is MSE property, but there's no MSE comment in there. So again, this is a particular constraint that appears only in my system because I define those annotations. They are specific to my system, and this is a piece of query that is valid for me only. And this is how easy you can basically go and detect it, right? As soon as you see your source code as data, it's nothing but it's just a fancy inspector that you have in there. But here's the really interesting thing. The really interesting thing is that I have now 36 places that I should care about. But if you ask me to order these things, I will tell you that all those that start with Famix are much more important than anything else. Because Famix is the core meta model. And this is what gets shipped to other people in other languages. This is what they see. And if we have a property that is not properly commented, then this is not good. It's much more important than any other property that we might have in the system. So in this case, basically, I want to say, is there anything that follows the Famix convention? And out of those 36, I have now 16 to focus on. And this is my to-do list. And what I can do right now, if I go back in this history of this tiny tool, this is basically it's a simple Smalltalk query I can write. All I did here is totally accessible from a Smalltalk point of view. And once I have this, I can integrate it in a continuous environment check. And I have it running all day long. And that's the idea. This is where the proposition around Moose changes the things. changes the state of affairs. I want you to be in charge of the queries you want to run across your system. Just like you want to be in charge of your tests, but the tests only capture the functional side of your system. They don't capture, for example, the structure of your system. And the structure is equally important, and it should be treated with equal respect. So, questions? So going back to the presentation, essentially, you want to have multiple tools around you, and you want these tools to be combinable the way you want to combine them. So here, for example, we said, well, you know, we have metrics, we have queries, we have various kinds of properties. You can use them in an integrated manner. You use Smalltalk as the query language, and it's highly iterative, right? This is key. It's really number one. Then we have all sorts of visualizations and the pictures. You know, when we say visualizations, by the way, we don't say UML, but we say a picture that you can throw against a piece of data, and then it tells you something about that piece of data. Okay, it gives you, you know, it reveals structure, it reveals information about your system that you otherwise wouldn't be able to have. So, and then you can start also combining these kinds of things with visualizations with queries, and you start highlighting things on them, and then it starts to become a different kind of a tool. And afterwards, we also have browsers. And by browsers, we mean a special kind of user interfaces that are dedicated solely to exposing or to letting you traverse and navigate data. That's what a browser is. It is a user interface, but it's a special kind of a user interface. Okay, so this is pretty much it. But the key, the real key, I mean, this is already interesting, but the real key in Moose are those things. Those are dots, by the way. I don't even pretend to know the exact problems you will need to answer. I don't even want to. And here's why. Because if you take a look at this picture again, the data is not just slightly, you know, contextual. It is highly contextual. Your system looks like really like no other, and the problems that you have, the actual problems, you're very likely to be the only one in the world that has exactly this particular problem. What we can predict are classes of problems, but not the actual problems. So that means that even, you know, sometimes I can't even predict the language you're going to be writing it in. Because maybe you'll start doing stuff with a string inside your Smalltalk code, and all of a sudden, you know, that's it, it's gone. So I can't even predict what kind of importers you will need. Of course, in most cases you will be able to use a streamlined language, and we will have something for that. But sometimes you're going to use a DSL, and all of a sudden you need a new kind of an importer. And then sometimes you want to represent your data in a different way. Like, for example, we have in Moose not just the regular Smalltalk structure, but we have these annotations that are separate. And basically we have another model that is parallel to the Smalltalk one and lives together. And we should be able to visualize that one as well. And similarly, I don't even know what kind of analysis you will need at the end, right? Models might change, and maybe even analysis might change. So the second feature of Moose that makes it really stand separately from others is the engine part. What we want to do is we want to make Moose a platform, right? Moose is not a tool. Moose is a platform primarily. And that means that it is made, its goal is to have you create your analysis fast. Now by fast, I mean really fast. So my target is 15 minutes. I want to bring the cost of building an interesting and relevant analysis to under 15 minutes. And this means all the way from going from a query to a metric to a visualization into a browser in under 15 minutes. So that's the task. So, questions up to now? No. So let me go and demonstrate a couple of things. So how many of you have heard of Mondrian here? Okay. Glamour? Okay. So I'll be demonstrating them a bit. And I have another talk in late afternoon at 5:30, I guess, that will be going more deeper into the model of Glamour. But I just want to demonstrate a bit. We'll just play a bit with some of the pictures here. So one thing we saw is that, well, we can take a look at the hierarchies of classes, and then we saw that we can map, for example, on every node we can map number of methods, number of attributes, number of lines of code, and so on. But now we saw that maybe annotations are important. So could we quickly see where annotations are, how are they spreaded in our system, and how they are not? So to do that, what I will do is I want to create a small visualization that shows me a hierarchy of all the classes, and then I want to see which classes uses how many annotations in there. Okay? So what I will do now, I'm right-clicking on all the classes in my system, and I'm opening it in the Mondrian easel. Mondrian easel is the editor for the visualization. And here basically I'm saying, well, okay, I have basically a script in here to the left, and I have a set of variables here to the right. In this case I have only one variable, the one I clicked on. It's going to be called class group. So now I can just simply say, okay, could you please create me nodes for all the entities in this class group? Right, so now I have 1,373 nodes. Then, well, okay, let's quickly draw edges and create a hierarchy. So you see the edges are drawn now here, but we have to lay it out properly. So I have my visualization here. That's great. But now what I want is I don't just want to have squares, but I want to, if possible, I want to highlight the amount of annotation instances. So how many annotations are there? And if there are any, I want to see them in red. So let's say I use a rectangle now, I define a rectangle, and then for this rectangle I want to say that the border color should be something like, so for each of these classes, if the class so I can simply define this, and that means I'm just reproducing the same picture as above. So I said, okay, just use me a color black. But now I have a problem. How do I know in a small talk to figure out how many instances, annotation instances are there? So I don't know exactly. So now I have a problem. What I want now is I need to go back and I need to retrieve this information somehow. So before I do that, what I would like is I would like to be able to click on one of these guys and right-click and say, can I go and open an inspector on you and figure out something? And basically what I would like is I would like to get the original mouse menu on every of those. Right? Not just have a picture there, I would like to have the original mouse menu there. So I say, okay, could you please give me change the interaction and then define the menu to be the mouse menu in here. And so now I'm reproducing this, and now if I click on one of these and I right-click, I can see, oh, I have all my menu in there. Okay, that's great. So could we, for example, could you please tell me, go to where this thing is implemented? Oh, so I see this is an instance of Famix class, and then this is a subclass of Famix type, and that here somewhere there's something like, oh, all annotation instances. Oh, great. So I just go and use that particular method. So basically here I go back and I say for each class, if this one here is not empty, if true, use color red. If false, use color black. Or maybe use color gray to make it better. So now when I'm looking at it, I can see that here there are some places where some annotations are being used, and I can move on, and boom, this big hierarchy over here are using annotations, right? And you can see how the information being presented in the context already takes a different shape. Now we would like to quickly see, oh, can we actually have it such that not just that I see that it has or it doesn't have, but show me how many. For example, let's map it on the height. Let's map for each of these. Let's map all annotation instances size. Right? I just want to say change the size to be bigger. So here there are not that many. And if I move along, oh, here there's more. This is something called MOEs as examples. And there's another hierarchy over here with a bit more, FM3 meta description, and boom, here, right? This is where lots of my annotations are happening. Now, what you see here is that basically at this moment I created a visualization on the spot with the pieces of information that I wanted, and I'm displaying them. And this visualization pretty much makes sense because there's value for me in there. For other cases, it might not make such a good sense. So this is what it takes. It took about 5 minutes. So you see, this is what Moose does. We ask the question, how much does it cost to build something like this? Because we know that you want to be in charge. So we need to be able to answer this question very, very little. Right? It should cost very little to build something like that. And so the next thing would be, then you saw, just take a browser, you take a dedicated browser, and you take a bit of time, you write some small talk, and there you go. Now, the next question is, how much does it cost? I would like to now basically see, I would like to see all the, it's great to look into this particular one, right? I'm saying, okay, here are all the annotation types, and then I'm clicking on one of them, like MSC property, and then I see that there are some in here, and then I'm navigating through them, right? I can see that. But what I don't see is, it's very difficult, right? I can't just navigate through multiple of these very quickly. What I would like is I would like to quickly say, well, could you please show me here on the left-hand side all these annotations, and when I move over them, I don't want to have the indirection pane in between. I just want to have a simple one. So every time I go through all these annotations, I want to see on the right-hand side all the classes in there. Right? That's all I want. Instead of having this generic kind of browser that basically I need to go through multiple steps. So now if I want to see all those that have common, then I have to go here, then I have to click there, and then I see it. Okay? So basically, I would need to build a browser from scratch. That's what it means. And I want to do it really fast. So now we're opening the Glamour browser editor, and we'll do a very simple browser quickly. So here I'm saying tabulator, and in this tabulator, I want to open the whole the whole thing. I want to start it on the annotation type group that I have as an input in here. And I just want to start with very simple 2 columns. So a column having annotations and another column having entities. And when I start the whole browser, I want to transmit the information from the outside. I want to transmit it to the annotations pane. And when I get there, I want to be able to show, well, I don't know, let's show a list in this case. And in that list, please display each of these things, right? So given the group, show me all the group. So now if I execute this, something happens. what happens is that I forgot one thing. So if I execute this, now I have my two panes here on top, right, in the preview, with all my annotations on the left-hand side. Now I just don't like the way they look, so I just want to say format, show me only the names. Okay, that's better. Maybe we sort them by X and Y, and the name of X should be lower than the name of Y. Okay, now it's better. Now I have it like this. Now what I would like is I would like to connect the two panes. So if I click here, I would like to show something on the right-hand side, right? So if I click on the annotations pane, I want to see something on the other side. So I will say, well, you know, take the output from the annotations pane and transmit it to the entities pane. Entities. And when you go there, please show me, well, let's say show me a list again. And that list, given that I'll now have an annotation type, again, now I'm navigating, I know my model, I know what it does. So I just want to say annotation type, annotated entities. Okay? And that's pretty much it. So now if I execute this, something is wrong. NT. Sorry? Entities. Yes, thank you very much. So basically now, if I go like this, I can now navigate the way I want, right? So it's there. And that's it. It can be that easy. And then I can also start embedding whatever piece of information I want in there. So I can display this in a different way. For example, I can display it by showing all the hierarchy in these classes or something else. Questions? So that's the idea of Moose. We want to ask how much does it cost to build a useful analysis tool, and we want to answer under 15 minutes. Now, why under 15 minutes? I'm highly stressed about the 15 minutes. Because, you know, if you are in a group of 8 to 10 people, let's say when you work, and you want to decide to go to lunch together, and the time elapsing between the first one saying lunch and the moment you're actually going to lunch is about 10 to 15 minutes. So if we can make this one productive, basically, you don't have to ask for anybody's permission to start working on this. Because the budget is already allocated. And if we provide the right platform, and if you have the right state of mind, then we can change the game altogether. And we don't change it, it's not a small kind of changing. So by the way, right, we just take a couple of things, just take a piece of code, you write it down, you can build a pretty complex browser that exposes the information that you care about. It doesn't have to be a fancy browser. It must be a useful browser. Because we said the only measure of success of an analysis tool is whether or not it helps us make decisions. If it does, it's useful. If not, it's not useful. It doesn't matter how fancy it is. And so there is more information about it. You can, it's a book I'm writing about Moose. It's free, themoosebook.org. Now, one thing I have to stress is that I'm not the only one working on Moose. Actually, I'm just one of the many. So last time we counted, and since then we stopped, we counted about more than 200 man-years of effort around this platform. When we say 200 man-years of effort, we mean research and development, right? It started in research in 1996, and since then it's been continuously evolved in many ways. So this is the idea, right? This is what the technology can do, but still the essence is what you want to do with it, or what you should do with it. And this is where understanding that assessment is currently an implicit task is the very first thing you can do. Understand that you're spending a lot of time doing highly manual work against a target that is ever larger. It simply doesn't scale. And it takes, it's enough to start spending 15 minutes per day thinking about this particular task and what you can do to improve it. It's not necessarily easy. It requires, if you go and you want to use Moose, there is a learning curve, definitely. But maybe, if you're in Smalltalk, you can already leverage the Smalltalk tools to a very large extent. Right? You don't necessarily need the Moose meta model to start querying your source code. By the way, what I will be showing you is exactly what in the next talk will be how to build a tool that is dedicated to objects, not necessarily to source code. It can be applied to anything. And you can start doing it with your regular Smalltalk know-how. And so, understanding that this is an implicit activity is the first thing. And we have to move on from having it totally implicitly somewhere under the rug. We have to bring it on and make it a primary activity, because it costs us too much. It's not something you don't notice, because it's too expensive to leave it like that. And that's the essence of it. So, at the end, what I want you to take away is that assessment is a human activity. It must become explicit during development, because it's simply economical. It makes economical sense to have it so. It must be tailored to your context, because this is where the value is. And you have to start thinking actively about it and start educating the skills required to approach this problem in a different way. And it is exactly because it's not the tool that is primary that I decided to call this one humane assessment. Where, by the way, humane means not of humans, but for humans. So, thank you very much. Questions? Yes.
Hello.
Hello. Hey.
During the talk, you said that using the tool to predict the type of problems that you will encounter, you could predict the class of problems.
The classes.
Not specific problems, because they're,
Right.
So, I think you use this tool quite a bit.
Yes.
And so, other than trivial things such as objects with 200 instance variables are bad,
yes,
methods that are generalized are bad, what patterns of problems that can be easily corrected in the first place have we found that are not necessarily true? What can we do to prevent the problem in the first place?
Well, it depends on what you understand by patterns, but the one pattern that I saw that has a tremendous impact is when you get the developer to say, I want this checked. Whatever that this is, whatever value is for the developer, when the developer says, I want this checked, the game is won. This is the very first thing that you want to get them. So let me give you an idea. So suppose I was working with a company that they have a client-server application, very trivial, right? And so good, excellent. And then, of course, you can check and say, oh, the client should use the server in this and that way. That's one way of doing things. But at some point, they decided, well, you know what? We have a problem that on the client, we have exceptions that are being popped out all the way from the server directly in the face of the client, like in the user interface. And you see JBoss, blah, blah, blah. By the way, that was Java. And then, well, their problem was that this was very difficult to expose in a functional test. Very difficult, right? Very difficult to predict when the server will, to reproduce a server error. And so, much easier for them to say, wouldn't it be possible to somehow check that every possible path that we are sending errors through is error handle on the client side. This is what's key, right? Not the actual detection. The actual detection is important as well. But the key is starting asking questions. The pattern right now, when I go in a company, the first thing developers ask, oh, could you show me that code? Yes, sure, we can show you that code. Oh, could you show me large pieces of classes? Yes, you can show you that. But the key ingredient is to start asking relevant questions. This is the pattern. I understand that it sounds a bit fluffy, but this is where the value really, really is. You have to change what you put in this tool, or in any tool you're using, to make something out of the output. I don't know, did I answer the question? Okay. Other questions? Yes?
Have you thought about the consequences of using these in the development?
My question comes from, for instance, many years ago when we started to write unit tests all the time.
Yes.
That was to make sure that the system worked as expected.
Right.
But then the testing activity became like TDD, so had an impact on the way we develop and think about software.
Exactly.
So have you thought of those kinds of consequences
Right.
of understanding the code this way that could come to the developing activity?
Excellent, excellent question. This is why if you go to humaneassessment.com, that's a method. It deals with the way you integrate this in your process, when you want to invest in it, how you want to invest in it, why you want to invest in it, and how you integrate it in the organization. Because it's exactly like you mentioned, somebody has to do it, we have to allocate resources for that, and we want to do it in some sort of an economical fashion. And that is why the philosophy around the whole Moose as a technology is key, because you want to deal with this problem. In reality, it's very important to go and embed this in the living organization and make it a daily reality, daily activity, such that you can actually take advantage of it. It's an excellent question. So, yes, another question.
Yeah, I have two questions. First,
Yeah, two.
We have some, we have a success story to tell us, to talk about. And
Many.
well,
Yeah. Yes, yes, and the other one?
And the other one is, if I want to learn Moose,
Yes.
how do I use Moose to learn about Moose?
How do you use Moose to learn about Moose? Excellent question. So I will answer the second one in my second talk.
Oh, okay.
Okay, because I'll be actually using Moose as a means to, we'll just build a small documentation tool for it. To traverse, for example, the meta descriptions. We have tools that we're building to help us understand Moose, to help us debug Moose. And let me just show you one problem. So I mentioned Glamour. Now Glamour is a prototype-based tool. Maybe you're talking about the first one. Is a prototype-based, has a prototype-based design. Whether or not that's a good idea, it's a second issue. But so the idea basically is every time you're seeing an interaction going on, lots of objects get copied at runtime. And so at some point we have this problem. Then basically the cool thing about Glamour is that you can actually describe the structure you can visualize the structure of your browser. Now I'm not going to go into details here. This is how a particular browser would look like when visualized using, for example, Mondrian, right, inside. Now we had this super interesting problem, and Esteban, for example, he tried to help me in various ways. And our problem was somehow, somewhere, we were not copying something properly. And you have to understand that there's quite a deeply nested object graph in there. And things can just somehow happen. Now we had the problem for about half a year. It was a real problem. And we tried to use the debugger in all sorts of ways that were invented or not invented, and simply could not get to the problem. So then at one point I said, well, you know what? What if we're using, some of these techniques to maybe make sense? And so I took like 2 hours and I built this visualization. You don't have to understand exactly what it does. What I want you to see is this. On the left-hand side, this is the model. These are the objects that reside in the abstract model of glamour. On the right-hand side, we have the rendering objects. So these are the actual morphs you see. Okay? Now, what we wanted is we knew for sure that we only want one rendering object per model object. So if you see somewhere 2 edges that go in the rendering object, so 2 of these red edges that go in there, it's not good. And so take a look at this here, right? This one has one that goes here and one that goes here, right? So somehow these 2 were not copying, we're just sharing the same rendering objects, and some problem resided from there. It took another half an hour to fix the issue, and then at the end it looks like this. Now, this is a success story for me in 2 ways. First of all, I understand that I was, it's a humbling experience to understand that whatever you're preaching, you're not practicing. And the other one is, honestly, this was there, it was a big issue for literally half a year. And it took 3 hours to fix it. Approach properly. That's just one example, but there are many others. I can describe some more during the talk, during the breaks. So.
Yes, just one.
Yes, another question.
I guess this is dynamic if you are working in Fire with a project, so
yes.
you change the project and everything refresh.
Right.
But have you thought, or have you something to say about software that is written under platform, under smalltalk?
Yes. One thing I didn't show you, for example, is the way we can use the queries that I showed you to build a browser that shows us, these are like tests, but queries, moose queries. They become red or green, and then based on that, you can display this or that information. By the way, this is the dedicated browser that shows the problem of the propagation of errors from the client to the server and so on. But it doesn't matter. What's more important is all that code, you press a button and you integrate it in your continuous integration environment. And this gets run all day long. And basically, from here, what this task does, this is Jenkins, this is, well, in that case, Hudson. But it's a continuous integration server, and it builds a moose image after, if you want, every commit in your Java repository, for example. And then you have your report basically pretty much up to date all the time. And this just works out of the box. So.
Okay, thank you very much.
Thank you.